we now have the tools of Gaussian elimination under our belt, as well as Gauss-Jordan elimination. So let's put those into use with some other exercises. And also remember that when we were studying systems of equations, we got a unique solution, meaning one solution. We got inconsistent systems where we had no solution, and dependent systems where we had infinitely many. So maybe, I guess we haven't seen any examples of inconsistent or dependent systems. Okay, foreshadow, foreshadow, foreshadow. All right, so we're supposed to solve the system using matrix methods. When we do that, we get -1, or 1 minus 2, and then again, recognizing x and y are switched here, be careful, 4, 8, and then we get 5 and 2 across our dashed line. Okay, so what I'm going to do is, this is my augmented matrix, use Gaussian elimination, so 4 row 1, row 1 plus row 2, put that into row 2, and I get, okay, first row remains unchanged, 5, and then I'll have 0, 0, and then 22. What do I do here? I have 0 is equal to 22. Inconsistent system. Okay? You can't have this happen. So this just means that the solution set is empty. Okay? If you wanted to translate this back, it'd be 0 is equal to 22, and then we cry, and we also have x minus 2y is equal to 5. Okay, you can write that out, but I wouldn't, because it's a waste of time and energy. Okay, so we have an example of an empty set, and so all right, let's get this one started. Start by writing the augmented matrix: 5, -9, -33, and 3. Oops, let's make that a little bit bigger. 1, -2, -7. And I want to put that closer together, and 0, and then -2, 1, 8, -12. All right. Now, in my own work, I restarted this thing about 3 different times. So, and it was because I forgot signs, so watch your signs. Okay. I'm going to interchange row 1 and row 2. When I do that, I get 1, -2, -7, and 0. Okay, and I'm going to forego the dash line just for speed. And then I'm going to have 5, -9, -33, and 3, and then -2, 1, 8, -12. Okay, now take a moment and just check your signs, make sure everything is good. Okay, all right. So then the next thing that I'm going to do, and I'll go down the next line for space, is I want to knock out the 5 and the -2, so that's in row echelon form. So I'm going to do -5 row 1 plus row 2, put that into row 2, and then I'm going to do 2 row 1 plus row 2, or row 3, I'm sorry, into row 3. Okay, so continuing. All right, we get this matrix, and there we go. Okay, now what I'm going to do is we're looking pretty good for row echelon form. I just need to knock out this 3 here, so I'm going to take 3 row 2 and add it to row 3, and when I do that, I get 1, -2, -7, 0, 0, 1, 2, 3. Oh, that's lovely. And then, 0, 0, 0, and then -3. Well, I'm in that scenario, right, where I have 0 is equal to -3, so this is an inconsistent system. So that means the solution set is empty. And how I know the solution set is empty, or that it's an inconsistent system, is by this equation. If I have the coefficients is all 0 and then a non-zero constant on the other side, that's indicating that 0 is equal to a number, which can't happen. All right, so this was a quicker video where we looked at inconsistent systems, and know that we can also have dependent systems, which we'll look at in the next video.